Welcome back to Daily Dose of Space. Today, we're diving into two major discoveries, both announced recently and both focused on the same big idea: finding new worlds and finally learning how they actually work. First, astronomers have detected a brand new super-Earth only 31 light-years away, orbiting the red dwarf star GJ 251. It's called GJ 251c. And while it's not in the habitable zone, the way it was detected, and what we already know about it, makes it an important step in zeroing in on the kinds of planets that could host life. Then we'll shift to a breakthrough from the James Webb Space Telescope, the first complete 3D atmospheric map of an exoplanet, the hot Jupiter WASP-18b. For the first time, scientists can see how temperatures, chemistry, and winds shift across an alien world in real time. Two planets, two different techniques. One story. We are getting closer to truly understanding other worlds. Let's get into it. The newly found super-Earth, GJ 251c. Astronomers just confirmed a new super-Earth candidate orbiting the star GJ 251, a relatively nearby red dwarf in the constellation Gemini. The new planet, now labeled GJ 251c, is estimated to be between 2 and 4 times the mass of Earth, placing it firmly in the super-Earth category. GJ 251c orbits extremely close to its star, completing 1 year in about 17 days. Because of that short orbit, it receives far more radiation than Earth does, placing it inside the inner edge of the star's habitable zone. In simple terms, it's too hot for liquid water. This discovery wasn't just another exoplanet detection. Its significance comes from the method and precision used. The planet was found through the radial velocity technique using new, high-precision spectrographs that can detect extremely small stellar wobbles. The star GJ 251 has been studied for years. Previously, astronomers had identified one potentially interesting planet, GJ 251b, larger and cooler. But they suspected more signals hiding in the data. This new detection confirms that suspicion and suggests that the system may contain additional planets we still haven't found. Even though GJ 251c itself isn't habitable, the host star is exactly the kind that future missions like Habitable Worlds Observatory want to target: a stable, quiet red dwarf that could host small rocky planets in the habitable zone. The discovery of GJ 251c tightens models for the system and increases the odds that a third Earth-sized world could exist in a more temperate orbit, one not too hot, not too cold. Super-Earths like this are extremely common in the galaxy, yet we have none in our own solar system. Every detection helps scientists understand why our system lacks them, and whether super-Earths tend to form under specific conditions. This single planet gives us new benchmark data for red dwarf planetary systems, improved detection models for small rocky planets, and a clearer target for future atmospheric studies. Even when a planet isn't habitable, it can still point us toward ones that might be. Webb Telescope creates the first 3D atmospheric map. Now let's shift to something much bigger, brighter, and hotter. The object of interest is WASP-18b, a hot Jupiter located about 400 light-years away. It orbits its star in less than 24 hours, so close that tidal forces stretch it into a slightly egg-shaped planet. Hot Jupiters are ideal for atmospheric studies. They orbit close to their stars. They're large. They produce strong signals in infrared observations. James Webb used its instruments, especially NIRIS and NIRS-SPEC, to capture phase curves, measurements taken as the planet circles its star and shows different sides of itself. Those measurements let scientists reconstruct a 3D map of the atmosphere. The map reveals major features: a massive, extremely hot dayside reaching temperatures over 2,700 degrees C, a surprisingly cool night side, with temperatures dropping by hundreds of degrees. Very weak atmospheric circulation, meaning heat isn't being evenly redistributed. Evidence of specific atmospheric molecules, including water vapor. Even in this extreme environment, the temperature difference between the day and night sides shows that the winds on WASP-18b aren't transporting heat efficiently, probably because intense stellar radiation ionizes the atmosphere and interacts with the planet's magnetic field. This is more than a map. It's a new era of exoplanet meteorology. For years, models of exoplanet atmospheres were built mostly on indirect measurements. Now, scientists can detect chemistry changes across regions, track heat flows, model wind speeds, and understand the physics shaping entire alien worlds. This is the closest we've ever been to weather forecasting on a planet outside the solar system. Webb showing that we can map a planet's atmosphere in 3D means that within the next decade, this method could be applied to mini-Neptunes, super-Earths, and eventually Earth-sized planets in habitable zones. This single demonstration sets the stage for future life search missions to analyze worlds that may be far more Earth-like. That's today's deep dive. A super-Earth close to home and a 3D atmosphere mapped on a world hundreds of light years away. Two very different discoveries that move us toward the same goal: understanding how planets form, evolve, and maybe even support life. If you'd like more updates like this, stick around. There's always something new happening out there.